Hello, everyone. I'm Larry Chang, Best Center Director. Thank you again, Marianne, for that wonderful presentation. I understand you recently received a Lifetime Achievement Award for your tremendous work in energy efficiency. Very well deserved. And now I have the pleasure of introducing two colleagues from the Lawrence Berkeley National Lab. Here, our talk today is Building Performance Standards for Decarbonization. And both Joshua Kace and Travis Walter will be taking us through that. Let me just start off by saying a few things about Joshua. He is a senior program manager at the lab and leads a large research program focused on applied research, demonstration, and deployment projects used to accelerate the adoption of building decarbonization, including energy efficiency, electrification, and demand flexibility for the commercial building sector. And that also includes existing buildings as well as new construction. His areas of focus for those projects include overseeing technical analysis to support building performance standards and policies, technical assistance for building industry stakeholders, techniques and tools to support data-driven decision-making, and technologies and strategies for deep retrofits. Joshua has a tremendous amount of experience in energy engineering and commercial and industrial buildings, and as well as sustainable consulting for commercial real estate, along with software development for climate and decarbonization technologies. He helped to start and grow the energy management and engineering departments at Code Green, a leader in ESG and energy consulting for commercial real estate. He has been involved directly or indirectly with numerous ASHRAE Level 2 energy audits and retro-commissioning studies, holds a BS in mechanical engineering from Columbia University, and holds credentials as a certified energy manager and a lead operations and maintenance accredited professional. And turning to Travis, he is a senior scientific engineering associate at the lab, and his research focuses on energy and efficiency in buildings with an emphasis on statistical data analysis. He's the technical lead on the building performance database. He works with cities to help them understand the impacts of enacting building performance standards legislation. Furthermore, he analyzes the energy savings potential of new technologies and helps to develop the software supporting the standardization of building energy data. He's a PhD in civil and in environmental engineering from UC Berkeley and holds a BS and MS in mechanical engineering from the University of Washington in Seattle. All right, so I feel exhausted just reading off all of your credentials. So anyway, with that, I will turn it over to Joshua. Welcome.
Thank you so much, Larry. I appreciate it. You all can hear me okay?
Yes.
Great. So let me just go ahead and share my screen. Thank you, Larry, for the very detailed introduction. Just as a initial sort of introduction here, I'd love to give you a little background and context on what I'm planning to present here today, which is around building performance standards. In terms of my own personal introduction, as Larry mentioned, a lot of that bio there was private sector work, which is where I've spent a vast majority of my career, sort of at the intersection of energy and climate technology. I am relatively new to the lab here, so I started November 1st. I actually just moved out to California from New York City exactly 1 week ago, so I'm also in a new home here. So hopefully everything goes well from an IT standpoint, but if not, I apologize in advance. But yeah, as you know, starting on my third month here at the lab, I am still a bit of a kid in the candy shop in terms of all the great work that the lab is doing, all of the amazing analysis, insights, research that similar to what Marianne was talking through before. It really is an honor to be part of this team and to be driving forward a lot of this work related to building performance standards. So that is all to say that the case studies I'm going to be presenting today were ones that I wasn't directly involved with, although I am doing the carry-on work to it. Travis Walter was directly involved with each of these, published a fantastic paper called A Tale of Three Cities related to these three case studies. Anyone who is interested in that, please let one of us know. I'll have our contact info at the end, and we're happy to share the information there. Building performance standards are a huge topic within our industry right now, but it is a bit of the Wild West as well. So it's really important for us to make sure that we are looking at boots on the ground, what's happening with building performance standards, in addition to the policy making process and some of the nuance that exists across different jurisdictions that we're working with. I will also note that I am not the only presentation during this conference related to BPS, which I'll be referring to as building performance standards. Peter Alsbach gave a fantastic talk yesterday, sort of a more broad overview of BPS and the implications to the building design process. I think also soon after my presentation, Chris Halfnight is going to be giving a more drill down talk around gas bans and zero emission appliance standards, which is also a key component of the broader BPS landscape. So definitely recommend you stick around and check that out as well. Just to quickly run through the agenda here, I'm going to give a high-level overview of BPS. Again, Peter spoke to a lot of this yesterday, so I'm not going to get into too much of an overview. But then I'm going to dive deeper into these case studies. So we have 3 different cities that we've done recent work with, Seattle, Aspen, and Berkeley. I will try to spend a little bit more time on Aspen and Berkeley as they're more related to the policy crafting around BPS, whereas the work we did with Seattle was a little bit more focused on their tune-ups program and sort of leveraging some of the empirical data that's been generated through that tune-up program. But there are BPS implications, and I'll get into those as well. So just by way of background here, there's no illusion that cities and states want to decarbonize buildings. Certainly not every city or state has the same motivation there, but there is a tremendous groundswell of support around efforts to decarbonize. And this is citywide, this is statewide, this is municipal-wide targets that have been set, public targets, mandates saying that we will reduce X% by X year. We will be net zero in terms of carbon emissions by a certain year. But how jurisdictions get there is something that is still a bit of an open question. And so there's a lot of different tools that can be used as components of pathways towards decarbonization. I note a few of those here. So Marianne briefly mentioned benchmarking, which is one of the most important first steps in most cases when it comes to decarbonizing. You can't, as they say, you can't manage what you can't measure. And so getting a good baseline of energy data across buildings is oftentimes an important step one. Another popular one over the past 10 years or so has been mandates around energy audits and retrocommissioning studies, also strategic energy assessments, building tune-ups. Sometimes the semantics overlap, sometimes there's a little bit of difference here, but the general idea of these two categories is that energy audits are delivering pathways for buildings to decarbonize. So recommendations, energy conservation measures, capital improvements that yield energy and carbon savings. And retrocommissioning studies are more operationally focused around how can I squeeze efficiency and performance out of the existing equipment that I have within my building. So both of these are typically prescriptive, meaning a building is required to complete the study, oftentimes with retrocommissioning required to complete work at a building related to issues that are identified, but they don't necessarily drive performance in and of themselves. There's still follow-on action that's needed to actually deliver empirical performance over time. Building performance standards come into play as sort of everything else here is more of a bottom-up building by building approach. Building performance standards is much more top-down, based off of your property type, based off of where the building is today. We need you to hit a certain target by a certain year, be it an energy target or a carbon emissions target. And so oftentimes this is much more aggressive in terms of the effort that's needed to comply relative to these other tools. And I think that's why it's important to make sure that there's sophistication and nuance in the way that they're implemented. As you can see, this is a map showing some of the cities that have either already implemented energy or emission targets for buildings, or have passed the legislation and are looking to implement the policy guidance, or they're just considering it at this point and sort of exploring whether it's a good opportunity. I think this map is even a little bit out of date. It has grown since then, and it is both cities and states, in addition to other jurisdictions like DC, that are looking at these standards. And so even though on the surface BPS is a relatively simple concept, right? You need to use a certain amount of energy. If you use more than that amount of energy, or if you emit more than that amount of carbon, there is going to be fines associated with your building on an annual basis. So if you're above your target, there's a real financial penalty there associated with it. And that's very easy to say from a top-down perspective, but when it comes to actually crafting the policy, there's a number of different factors you need to take into account. We have a few listed here. I think one of the most important ones beyond this list here is, how does electricity look on your grid right now? Marianne was mentioning this, California relative to Ohio in terms of cleanliness of the grid today, but also cleanliness of the grid in the future, right? How carbon intensive is a kWh of electricity today, and how carbon intensive is that kWh projected to be in 2030, in 2050. Those are all things that need to be taken into account when you're looking to set targets, either pushing people towards more electrification or pushing people towards energy efficiency and or scope 1 emission reductions. Here's a sampling of a number of the different policies that are already sort of in place. I will also note that these policies are really, really important beyond building codes because they affect existing buildings, right? This is a lot of the buildings that exist today are going to be around in 2030 and are going to be around in 2050. So new construction codes are very important, but they are missing a big chunk of the operational emissions of the building stock of a given jurisdiction, because a lot of buildings already exist, and policies need to be put into place to manage that. That does present all sorts of different challenges, not the least of which is a lack of standardization across BPS implementations. You can see here just the variety in the building type, scope, what buildings are included within this BPS ordinance. Typically, BPS is going to target larger buildings. Larger buildings do have much more of a realistic pathway to decarbonization than a smaller building, especially when it comes to some of the custom approaches that are needed. But there's also oftentimes legislative restrictions in terms of what buildings can be targeted for a BPS, sort of what the purview is of those that are looking to regulate it. And then timing around it, there's a lot of variation. And then beyond that, the performance metrics themselves, what are you actually setting a limit on? Is it like Boston or New York, are you setting a GHG target directly? So that's, take the electricity use of a building, the natural gas use, any other fuel use, multiply it by its associated emission factors, you get the carbon footprint of the building. Or are you setting a target around EUI, energy use intensity of a building, where you're not, by means of reducing energy, you are reducing carbon, but the target is not set on that. And beyond that, are you normalizing your performance metrics? So just as an example, New York City right now is a non-normalized target, meaning regardless of what's happening with maybe occupancy hours within your building, regardless of what's happening with the seasonal changes, if it's a particularly hot year, there's no adjustments that are put into place around their carbon limits. Other places, Washington, D.C. is an example, utilizing Energy Star score, which is inherently a weather normalized metric in addition to occupancy normalized. And so these are all the different sort of knobs that can be turned on the policy side. And there is no, one silver bullet answer here, right? There is a lot of variation and a lack of standardization, but sometimes there needs to be relative to some of the specifics of what happens within different regions. And so I'll get into some of the detail around that as we go. So again, as I noted, there are 3 cities that we're diving into here. Just in the interest of time, I'll probably hop through some of these slides a little bit quicker. But just broadly speaking, Seattle is looking at the buildings tune-up program that's been in place and what has the impact of that been, and where does that fit into the bigger picture of BPS. Aspen really looking to set EUI and GHGA targets. So questions that a lot of cities, states, and other municipalities have around, we're interested in BPS, what do we do next, right? Initial steps that are needed. And then Berkeley is a bit more of a, I guess I would say, special case from the perspective of they have a very clean grid already in Berkeley. What can they do to drive carbon reduction? Obviously, reducing electricity use, if your electricity is virtually all renewable already or all zero carbon already, is not going to reduce your carbon footprint. You need to focus on electrification, scope 1 emissions there. So those are the 3 different pieces that we're going to be diving into in some more detail. Seattle, again, as I noted before, I'll run a little bit quicker through these slides, but just broadly speaking, the goal was to take what I consider to be a treasure trove of data that came out of their building tune-ups program. One of the real benefits of retrocommissioning energy audit requirements beyond the energy savings that they deliver is the data sets that they're able to produce, right? So we saw this in New York City. My previous consulting firm was involved with analyzing local law 87 data, which energy audit data from studies that have been completed across New York City. And it's really interesting findings that you can get once you dive into the measures that are identified, the buildings, systems, and other characteristics, in addition to, in the case of this study, diving into the energy use before and after the tune-ups are completed, right? So how much of an impact is actually happening at the building. In terms of the data that we were able to look at here, so building characteristic information, systems, and energy use, as I noted, are all sort of the key components, in addition to looking at the actual issues that were identified. So these are itemized lists of tune-up issues. So things like reviewing schedules, checking sensors, checking filters, things like that. In terms of the data set of buildings that we were looking at, there were 420 total buildings for which we had this tune-up data available. Unfortunately, only 82 of those sort of passed muster when it came to pre and post tune-up energy data, and that is mostly due to the pandemic. So obviously, as the pandemic hit, building occupancy patterns changed dramatically in both directions, right? Residential buildings using more energy, commercial buildings using a lot less, as a lot of them were vacant. And so we were only able to leverage 82 of those buildings that had a solid year of post tune-up energy data prior to the pandemic hitting. And so that was one of the unfortunate limitations here. And so what did we see? Energy savings, I think, was one of the key things we wanted to look at as a starting point, right? So energy use before the tune-up, energy use after the tune-up, we saw a lot of variability, which is, I would say, very much not surprising, especially given a relatively limited sample set here. But the top line findings that are really important, there were real energy savings that were realized on a median basis. So 4.1% site energy savings was what we were seeing post tune-up. And that is, and the other sort of very interesting finding here is that 34% of the buildings that were looked at, 34% of those 82 actually increased their energy use after the tune-up, right? You would not necessarily expect that going into something that is meant to deliver operational efficiency to a building. But there are a number of reasons why this could be the case, not the least of which, having delivered these retrocommissioning studies in New York City, one of the things that was often identified was equipment that was just not working. Domestic hot water heaters that weren't delivering hot water or weren't delivering it at the right temperature. Maybe it's an AC unit and one of the two compressors is not working. So during the hottest days, it was struggling to hit its set point. Those are things that do yield less energy use, right? Because the compressor is literally not running. Outside air dampers were another big one, right? Outside air dampers that were stuck closed. So you were recirculating a lot of air within the building, which isn't necessarily great for the occupants, but does yield energy savings because you're not conditioning outdoor air. And so I think one of the bigger picture findings here from a BPS standpoint is that tune-ups are important to make sure that buildings are delivering their original functional requirements, that you're delivering comfortable space temperatures, that you're delivering enough ventilation to spaces, you're delivering hot water on demand as needed. And that is sort of the backstop that should be used for follow-on BPS legislation, right? You don't want people turning off equipment within their building that is considered important equipment just to adhere to a BPS target or limit. There were a lot of other things that were looked at over the course of the study. This was very much an exploratory study trying to look at, what is the heating system age relative to some of the weather normalized energy savings that we're seeing, or the year built of the building. Was there a correlation there to the savings? The top line answer is no. There was very little correlation that was seen across most of these parameters. But that being said, that in and of itself is an important finding, right? I think that is telling us that it is difficult to target specific systems or target specific property types when it comes to tune-ups. But at the same time, you are still seeing that 4.1% energy savings with limited targeting happening as part of that. So I think those are things that are important findings to keep in mind when it comes to broader BPS policies. But yeah, I think this was a fantastic sort of initial study, but this is the sort of thing that could be done more and more with more and more buildings to help identify more and more real correlations that allow you to target policies in even more sophisticated ways. Hopping on to Aspen here. So Aspen, we are looking at, again, implementation of BPS targets. They had a broader emission goal of 55% by 2030 and 0 by 2050. Just doing a time check on myself here. I see that I don't have a tremendous amount of time left, so I will have to hop quickly through these as well. But one of the interesting parts of this is that there was no benchmarking data for us to work off of when it came to understanding the impact of a BPS target. So we did have to use tax assessor data to understand the building stock segmentation. And then we utilized more centralized resources such as CBEX and REX to sample energy use across the different buildings. So develop estimates for the annual energy consumption. Even though we didn't have access to empirical energy data, there's still a lot of great findings that you can get out of just looking at the building stock and the levers that you're turning in terms of your BPS targets. So a couple of the interesting ones here. EUI and GHGI targets was one of the comparison points, and both delivered relatively good reductions. You could see here, red is representing the base case. Red is behind the blue line here. base case meaning no BPS target at all. You may be wondering why there's still major reductions happening here. That's essentially projections of the grid getting cleaner within Aspen. Aspen today is a relatively carbon intensive energy mix, generation mix, but over time they are looking to dramatically reduce the amount of carbon intensity within their electricity. And so that is what the reduction is that you're seeing with even the base case. And you can see that the various scenarios here do give a marked additional increase with EUI and GHGI targets. And obviously being able to target single family gives you an additional chunk of savings here that you wouldn't see otherwise. The other big finding from the work with Aspen was electrification in and of itself. So just switching out gas equipment with associated electric equipment was barely better than the base case. You can see it sort of hidden here behind the base case for all of these years going up to 2035. And the reason for that, you can see the emission factors here. Electricity does reach a point where it is going to be less carbon intensive than natural gas. That point is around 2033, which is here. Even though the electric line is higher than the gas line, electric equipment is much more efficient than gas equipment on a BTU per BTU basis. And therefore, even though the electric intensity is still significantly higher, the coefficient of performance being 2 or 3 of the electric equipment makes it a better option starting in 2033. But this is a very important and interesting finding, right? You don't necessarily need to electrify earlier on. It doesn't deliver any benefits at all through 2033. But in accordance with the grid getting cleaner, you do definitely want to target electrification at a certain point. The other big finding here is that, as you could see, those targets didn't get them to their zero goal. Getting to a net zero goal entirely is a very, very difficult thing to do. So we weren't necessarily surprised by that. These were modeled after realistically achievable reductions here. But as you can see, it does do a big chunk of the progress. And so it's very important to implement these sort of things to get a majority of the way there. So that was some of the interesting findings from Aspen. I'll hop quickly into Berkeley. As I introduced before, electricity is essentially zero emission already. So their goal was to implement policies that allowed for electrification. Electrification upon replacement was the way that they wanted to approach it, which makes a ton of sense. Marianne and the listener, Robin, were talking about embodied energy and embodied carbon. You don't want to take a brand new piece of natural gas equipment that was installed in a building and rip it out just because you have an electrification mandate, because there's a lot of embodied energy within that piece of gas equipment, beyond it being very unaffordable for a property owner to replace a brand new piece of equipment. And so their policy was built around the idea of requiring electrification at equipment end of life. And so by taking audit data, in addition to end use load profile data from Comstock and ResStock, we had to sample from the Berkeley data set as much as possible. And then when data was limited, we also looked at the San Francisco building stock and available data there to start to understand, okay, equipment has a certain useful life. If people are switching that out with electric equipment at the end of its useful life, what are the trends that we're going to see in terms of emission reductions? And so hopping through this quickly here, you can see that there is tremendous savings once you do have a clean grid in electrification. So juxtapose this with Aspen, where electrification through 2030 was having zero impact. Berkeley was having tremendous impact through electrification because they had a virtually carbon-free generation mix. We also looked at replacing 5 years earlier or later to sort of understand what the impact would have there. In terms of the endpoint, there wasn't too much of a difference, but in terms of the cumulative savings, so essentially the area under the curve here, there was significant amounts of change in the cumulative savings. So the earlier you can implement these policies and the earlier you can get people to switch out their equipment, obviously from a cumulative standpoint, you're going to be able to drive a lot more and a lot better performance. We also looked at a comparison policy of reducing natural gas use by 25% every 5 years. I think one of the limitations of a policy like that is you are more or less incentivizing further investment in your gas equipment by making it more efficient. If you have this sort of step down of 25% more efficient every 5 years, until you reach that point where it needs to be zero and you're replacing the equipment entirely. And so how much do you want to incentivize a building to invest more money in retrofitting a gas system if electrification is already an option here? But, you know, that being said, you could see all of these scenarios and the cumulative emissions savings that are seen. These are really, you know, interesting and powerful graphs when it comes to the policymaking process. But yeah, obviously the big takeaway here is that a lot of this work is dependent on the grid and what's going to be happening with the grid within a given location. So what are the big picture conclusions here? BPSs are important. BPSs on the surface seem very simple and straightforward to implement, but the devil is in the details with these things. And once you get into the weeds of it, BPS policy design is critical and needs nuance if it's going to deliver real energy savings affordably and realistically to the building stock across a jurisdiction. And so a lot of the work Lawrence Berkeley National Lab and the programs I'm overseeing are doing is directly related to further technical assistance on BPS implementation across the US. And there's some really interesting follow-on work that we're definitely going to be publishing and talking about over the next year. But as things stand today, BPS design is still the Wild West and still a really important place for us to be continuing to drive further energy performance and hit those goals that cities and states have to get to net zero by 2040, 2050, whatever the year may be. And huge shout out to Travis Walter as the lead on all of this work that I was able to present on. And he is here if there is a few minutes here for questions. So thank you everyone for the time.
Thank you, Joshua. I like your description of BPS as being at the frontier status right now, right? And you know, we only have time for a handful of questions. The first one is regarding the comparison between state versus city level BPS, right? And, you know, how would you compare the differences in standard setting and enforcement?
Sure. And so, yeah, there is definitely important nuance. There's certain things that are the same, right? From a technical analysis perspective, you have a stock of buildings. Typically, even at the state level, you're dealing with one, maybe two different climate zones. But you know, having multiple climate zones is something that is a additional complexity in the analysis that's being delivered. But mostly from an impact analysis standpoint, things are relatively the same. From a political standpoint, things are very different. And there are a lot of complexities associated with, you're typically then dealing with multiple different utilities. You're dealing with multiple different stakeholder groups in different counties. Also at the state level, you may have counties or cities within your state that already have BPSs being implemented or already have benchmarking policies that are being implemented. We're working with, as an example, the state of Maryland right now, and they're doing some great work to get BPS implemented across the state. At the same time, one of their counties has already been pushing forward BPS legislation specific to that county. And so there's nuance that's needed there when it comes to, there are certain things that work better for some counties relative to others, both in terms of the building stock, in terms of the utilities, data availability, all those different things. And so it is an important question and an important distinction to make. But at the same time, communication is sort of a key aspect of it, right? As long as there is open, transparent communication and coordination between the different stakeholders that are involved, you can drive forward policies at both the city level and at the state level that are harmonized in such a way that they're going to, deliver the best possible value for that building stock and for the area. But yeah, very important question to consider.
Yeah, very a complex stew, if you will.
Yeah.
And yeah, I really appreciate that comparison between Aspen and Berkeley, right? Just kind of given, okay, how does BPS get configured relative to just the very nature of how clean your energy is coming in to begin with? As a result of this study, has Aspen given any thought to perhaps saying that, okay, we can't really rely so much on BPS, especially if we want to do something before 2033, right? We need to go and get less carbon intensive energy to begin with.
Yeah. So it was definitely something flagged through this study, right? That was an important talking point for the city of Aspen to then be able to go to their utilities, to go to public service commissions and other regulatory agencies that have the power to drive the cleanliness of the grid over time. I do think from whether BPS should be held off on or not, they are still taking the tact of BPS is important. There may just be some nuance in terms of when the different targets are being set, right? So electrification is one of the major movements that you get from target setting, but you can set targets specific to electrification later on and set targets based off of more efficiency-based approaches earlier on, right? So there is still work that could be done front-loading, perhaps, electric efficiency across systems initially, just because electric efficiency benefits everyone, plus it's more cost-effective. And then driving the efficiency and eventual electrification of gas equipment once the grid is projected to be there is the next big component. But yeah, it was definitely an important question, and we're having ongoing conversations with Aspen about the best way to actually implement the policies across the board. So if that helps.
All right. Well, thank you so much. I know that we could continue this discussion much further. Hopefully, we'll see you on future webinars and institutes. So thank you so much, Joshua. And now I am going to introduce